Okay, in this first video here, we're going to do our DIP8 package, which stands for Dual Inline Package 8-pin. And this is going to use the, sorry, I lost my train of thought there, pad stack that we did in last week's videos and on your homework. So we're going to use those pad stacks again. Now what I'm going to do here for this particular one is I am actually going to use the Oporto system to show you how to be able to upload things and to set things up for doing this here. So first off, I have an Oporto open. I went ahead and launched Allegro, which you can just do OrCAD and Allegro products, and then the PCB editors right there. Now, I also have launched the pad stack editor, which is not the most obvious way to find it in Oporto. Let me close that here. If you try and search through these, you're not going to find the pad stack editor searching through these. If you click the start menu and try and search, there's nothing there at all. But if you click that start menu and you just typing in pad stack, you can see pad stack editor, and it says desktop app, which to me means it's somewhere on the desktop, but I have yet to find where the link is. If someone finds where that link is, more money to you. So let me move that to trash bin here. All right, but it's open. Now the reason I point that out is that if I'm going to make a footprint on Oporto and I haven't saved my pad stacks to Oporto, I'm going to have a problem because I need to have both my pad stacks and my footprints there. Let me go ahead and pause for a second. I was going to try and see if I could turn my webcam on, but I can't, so that's fine. Normally I have, or at least on some of the videos, I have my nice little face down here. So we need to make sure that we have our pad stacks, as I said. Now, if I go to the directory here, let me first show you again on Oporto. If I go to this PC, so I'm just in the File Explorer, there's this U drive, and this is where we really should be doing all of our work for Oporto, is we should really be doing it on the U drive. And so I log in, or double click, I should say, and you can see I have two directories, Cadence and MATLAB. I actually do know MATLAB quite well, and have taught the EGR 1500 course before. That's a side note. But if I go into Cadence, you can see what I've done here is I have two directories here. I have a footprints directory and a pad stacks directory. And that's important because we want to have a location to store these that, is easy for us to access and is different than where Cadence normally stores them. Now, to kind of here, I'm going to go to my local computer just to show you here. If I go to my local computer and I explore my C drive and go to Cadence 17.2, you don't need to know this, but I'm showing you as I go through all of these directories here. This is actually where Cadence stores all of its default pad stacks and footprints. So if you're ever using default pad stacks or footprints, this is where you would be looking as far as where they're stored. So let me go back to Oporto. So that brings up something that's actually the very first thing we need to do whenever we're going to be creating pad stacks. Actually, not when we're creating pad stacks, but when we're creating footprints, is I'm going to go into Allegro. You can see an example of what it is that we're going to be creating. But I'm going to go to my setup and I'm going to go to user preferences. Now, I've already increased some of those sizes there. So let me go back to the beginning here. So if you go to user preferences, this is what you're going to get here. Now, what we want to do is we want to look under the paths. The paths are where it contains file path names, or actually directory names on where files are stored. So if I go into library, there's a bunch of different ones here. We're not going to be concerned about all of them, but we are going to be concerned about the pad path to start with. That's where it points to as far as what directories to look for the pad stacks. So if I hit those little three dots, it opens another little thing here and it says pad path, $. What that means is it's looking for however you created the install of your Cadence software, it's looking in that created directory for all of the pad stacks. So the pad stacks that we create aren't going to be shown there. And we definitely don't want to store our pad stacks there, because if we store those pad stacks there, then we could get them confused with, the real ones versus the ones that are created by Cadence. So instead, we're going to do new, and I'm going to insert, and I'm going to go ahead and just navigate to U. And if you don't have it there, of course, you have to go to this PC, the U drive, and I created it under Cadence and pad stacks. So I'm going to add that directory in there now so that when I get ready to make my footprint, it's going to look in the directory on where I created my pad stacks. So I'm going to click OK, click Apply. It's not necessary to click Apply, it's just a habit I get into, and then click OK. Now, let's go ahead and look at the pad stack directory. Currently, for Oporto, I don't have any pad stack stored here. And the reason I don't have any pad stack stored here is because I didn't create any pad stacks on Oporto. I created them maybe on my computer at home, or my USB drive or something like that, my student account. So I don't have my pad stacks on Oporto. So either I need to recreate them or I need to upload them. Well, I'm going to upload the pad stacks, and so I'm going to go to File Upload. Now, when you go to File Upload, you can upload more than one file at a time. And I'm already in my OneDrive Cadence pad stack folder. So I've got several pad stacks here, but the ones that I'm going to do are the 0.9 millimeter hole. Those are the ones that I need. So I'm only going to upload those. And now I got popped up that it successfully uploaded those files. Now, the question is where? Well, by default, it uploads them to the desktop. Now, I don't like having them stored on the desktop, so I'm going to select both files, do Control X for cut, and then I'm going to paste those into my pad stack directory. Okay, so now they're in my pad stack directory. Great. Now we could say I'm ready to create my footprint. But at the beginning of this video, you may have noticed something that was open, which is actually going to pause here from it. Just like we have a naming conventions for our pad stacks, which, as a side note, I found another nice PDF that summarizes all of the naming conventions for pad stacks. We also have naming conventions for the components, for the footprints. Now, this document, which I will upload as well, has at the top surface mount components. Well, we're not doing surface mount components at this point, so we need to scroll down. And there's the suffix naming and everything, but I'm going to keep scrolling down. Oh, it says surface mount here for non-standard. Okay, well, I don't have that. Okay. Ipc Standard for through-hole land patterns. And it gives some information. The land pattern name convention uses component dimensions to derive the land pattern name. First 3 to 6 characters in land pan describe the component family. The first number name refers to the lead spacing or hole-to-hole spacing to insert the component. And that hole-to-hole spacing is referring to the width of those spacings, not the spacing, like for instance, in the picture that's referring to the dimension that would be the spacing between pin 4 and 5. not the spacing between pin 3 and 4. The spacing between pin 3 and 4 is called the pitch. So, and then it's got some other things as far as what these things mean. And so if I go here for dual inline packages, because it's what this is, we're going to have a dip plus lead span plus W, which is my lead width then, plus P for pin pitch, plus L for body length, plus H for component height, and then plus Q for, and then pin quantity there. And so if we want to make sure, again, we have here the lead span, W, lead width here, we can look for any kind of information. And then it also says at the end, you'll notice if you look at this example, there's a B at the end. So we end it with A, B, or C are for the fabrication levels either A, B, or C. And remember, by default, unless otherwise specified, we're using fabrication complexity level A. All right, so let's figure out what the name should be here. So let's pull up this data sheet here. And let's go through here. And I'm going to write it down on a piece of paper. So I know it's going to start out DIP, dip. Let me zoom in a tiny bit. So lead span, well, lead span here, minimum and maximum here, and we could do a nominal. Now, if you look here, a dip is kind of a standard paction. They did 7.62 here on their example. So they are actually using the minimum number here. Remember, we were going to use the maximum for a lot of times. For this example, I'm going to use the nominal values for everything. And I'm going to do that just to show you how you can compute nominal values when you're given this. So I have 8.26 millimeters as the maximum plus 7.62, which is the minimum, and I'm going to just divide by 2, which is 7.94. So I'm going to have dip my lead span, which I'm going to do as 794 because it's 7.94, and then I'm going to do a W for my lead width. Now they have it here as 0.52. Well, let's see, what is my lead width here? The lead width here, maximum it says is 0.53, minimum it says is 0.538. So in this case, they essentially were going for the maximum as far as the lead width, but we're going to go again for the nominal value here. And you may say, why are there different values? Well, remember, some data sheets only report a single value as opposed to a range in values. Okay, so I'm going to do 0.53 plus 0.38 divided by 2. Whoops. Order of operations, 0.53 plus 0.38, then divide that by 2, and I get 0.455. Now I'm going to round that to 0.46 so that I would have W46. And then pin pitch, well, that's this measurement right here, 2.54, that's correct. So plus, so that's going to be P254. Now I need body length, L, which my body length at 19.05 is what this is saying, but this is for a 14 pin. But if I look at here, my body length here, if I'm using my nominal values, 10.16 plus 9.02 divided by 2, I have 959 for my body length as far as my nominal value. And then, where am I here? I'm on my dip here. And then it's got component height, which is then H. And here it says 5.08 for the component height. Now, I'm not, I'm sorry, I know exactly where that comes from. So component height here is the component height, and you see there's this little gap here. We want to include that gap. So it's this distance here, because it's not going to sit like literally with the bottom of the chip on the board. And that's because these pins are wider. They're wider on purpose here so that it won't actually, sit there, so that there's no chance of like any kind of, damage happening. And also so there's a tiny bit of air gap as well. So that is going to be 508 for my height, and then plus Q, and the pin count, which is 8, and then my complexity level is A. All right. So using this name convention, going back to Oporto, I'm going to now do File, New, Package Symbol Wizard, because we're actually going to just use the wizard this week. We're going to do dip 794 W 46. Wait a minute. I said 46. That I want to make sense. That's, yeah, 46, because it's 0.46. Okay, that is correct. Just wanted to make sure. I thought I got myself sidetracked here for a second. Pitch. Click back in here. Pitch 254. Length 959. H 508. Q 8A. And so I can see my long name here, and it's pretty long. And if you look at what Cadence does, Cadence actually does not follow this IPC naming convention. Now, before I go any further, let me maybe emphasize that the IPC naming convention is not always followed. It really depends on the company that you use. Some companies choose to not follow IPC naming convention because they want their parts named a particular way. Like for instance, they don't want to use just a generic footprint for a part. They actually will want an actual component manufacturer ID for that part. There is a company in Fort Wayne that they literally, for every type of resistor, when I say every type, I'm talking about if it's a 1 kilo ohm resistor versus a 10 kilo ohm resistor, even if it's going to be, quote, the exact same footprint, they actually have two different footprints names, one for the 1 kilo ohm, one for the 10 kilo ohm, even though the dimensions within the footprint might all be the same. And that's because they're getting to a specific level of actual like manufacturer's parts. So there is this IPC standard, but not every company is going to follow this naming convention. But since we're teaching IPC standards in this course, we're going to follow the naming conventions. So then we hit next, and we always need to load a custom template in. It's going to always give us this warning. I'm going to hit yes. Next. Now remember, we are going to do everything in millimeters. So I'll go ahead and put the decimal points up to 4 for no reason. Now this reference designator, by default, when you're doing a chip, it's going to do a U here. It does not have to be a U. If you do a drop down, there's other ones. Now you can imagine R and C are for like resistor and capacitor. J is usually like for jumpers or connectors, things of that nature. But just because those are the only choices does not mean that's all we have to do. I could do a T instead, even though that's not in the drop down menu. But we are going to do U because that is standard for chips, for integrated circuits. Now this little asterisk afterwards is really to append on from the circuit diagram if it's like U1 versus U2 versus U3. So if there's a number that's following it, like often resistors, you'll have R1, R2, R3, so on and so on. It will append that reference designator information from the label in your circuit diagrams into that asterisk field. And so I'm going to go to next. And now, first thing I'm going to do is make sure to change this to 8 pins. Now the lead pitch was 2.54, so I don't need to change that at all. Now the terminal row spacing here, 7.62. Remember again, that was what the other had as far as the default, as far as 7.62. But that was going with, that's not what I want to look at. That was going with this minimum here. And we went with the average or nominal value is what we said. Now again, the 7.62 might be considered a nominal value on some data sheets, but we went with the average of the max and min. So that was 7.94 millimeters. And then the package width, well, that's nowhere in our name. The package width here, though, again, if we're going to do our averaging like we've been doing, we have 6.6 plus 6.1. Divide that by 12.7 divided by 2. So we get 6.35, which is actually what's right there. So that's why I said, again, using kind of the nominal value as the average. And then we're going to do the same for the length. So it's bringing up my calculator. I've got 10.16 plus 9.02 divided by 2, 9.59. And the default pins here. Now, this is all of the pins from Cadence, all the pad stacks. And so I've got to find mine in here. Well, I started one with a C. So if I scroll down, oh wait, I went too far. And if I go back up, oh wait, here it is. And you can see these don't necessarily follow the naming conventions that we've been looking at. So, and I had ended it with last names because that's what we had done in our previous week's homework, even though that's not an official part of the naming convention. Now, I also made a different one for pin 1 because I made one that had a square copper pad. Now, instead of going down through that, you can use this wildcard idea, this asterisk, to your advantage. I know a square pin is going to start with an S, and so if I do S star and then hit enter, it's only going to list the pad stacks that start with an S. And there's mine right at the top, S160H90 Rumsey. And then I'm going to hit next, next, and then finish. Well, let me, before I finish, did the pad stacks here. This here is just talking about the center for the location of the footprint, and center of the symbol body just means that it's going to put the origin like right here. If it was pin 1, it would put the origin up here. And then whether you want it to generate a compiled symbol for you, if you don't create a compiled symbol, well, then you have to compile a symbol. And so I just leave that as a default here. And then it tells you what things it's going to create. And we do finished, and we can see I get this nice footprint here. And it's got a bunch of different layers that we will talk about because it's got a U star here and a U star here. One's what's called a reference designator, one's a silkscreen layer, and we'll talk about the differences. And then it's also got all of my pins, the first one being a square, as we said, and you can see when we zoom in, you can actually see here's the drill hole, here's the copper pad, and then the purple is the solder mask. So we have our footprint created. So just save that. Now I was going to say overwrite it because we're always, if anytime you save it, it's going to ask if you want to overwrite it. Now if I go to my footprint directory, which is where I saved it, we will see my nice long file name here. So there's this DRA file, and then there's this PSM file. Both of these files need to be turned in when you turn in your assignment. And so if I was done, I could actually open an internet browser here, log into Blackboard, and upload the files that way. But let's say I need to, take a break or something. And I mean, I could leave them here, but let's suppose you want them on your local computer or your laptop or something like that. So let's say we want to download these. Well, the easiest way to download them is to copy both of them. So I'm going to select both, and then I'm going to do a Control-C to copy, throw them up on the desktop, and then use this file download, and then it will give me on the desktop here what files I can download. And so there's this one, and then there's this one, and then they would just download onto your computer and save in whatever directory you have as far as your save directory for the downloads. Now, just so you know, this symbol looks a little bit different only because I also have version 17.4 installed on my computer. So that's all we need to do to make a pad stack using the symbol wizard. As you can see, it almost took us longer just to figure out the name of the component than it did to actually create the component. Let me see, I think there was one more thing I was going to tell you or show you. Let me pause. I know what I was going to show you. I was going to show you a kind of slick way you can get around looking through all those pad stacks. So if we go to the file and we'll just start a new package, I'm just going to go without using any kind of naming convention, just call it test and do a package symbol wizard. Actually, I'm not going to do that yet. I forgot I need to change the setting. Setup, user preferences. I'm going to go back to this pad path. Now we have this $ pad path and then this C cadence pad stacks. I don't have to have that there. In fact, often companies will not have this path there because they don't care about the cadence predefined pad stacks. They only want to use ones that they themselves have created. So I'm just going to actually delete that. And then I am going to select OK. And then I am going to go ahead and do a new part. Package symbol. And again, I'll just call it a test. And I'm not going to do any kind of, it's just going to be dual inline package, load custom template. I'm not even going to worry about the fact that it's in mils. I'm just going to keep hitting the next button until I get to the pad stacks. But now we see I only have 2 pad stacks to select from because, well, it's only looking in that directory, which is only containing the pad stacks that I've created for. So I will actually do this sometimes when I'm running it at home on my home computer, because I don't want to use any of the pad stacks that Cadence has created. I only want to use the ones that I've created. And so that is kind of a slick way to make it so that you only see the ones that you've created, which makes it easier to select the one you want to use. Obviously, it's not required, but it is a nice little feature. The other thing I want to show you, and I'll just do this by hitting back here, is for your homework, one of your things you will do is probably going to use what's called an SOIC pattern, even though the actual package is what's called a SOT package, an SOT package, which stands for Small Outline Transistor. Now, you might say, well, how can I use the same one? And the reason is because it looks the same. It's just got smaller dimensions. So as long as the device looks like this, even if the package is not an SOIC, as long as it looks like this, we could use this wizard for the SOIC. The other one is that you will be doing one that, while it's technically not a zip package, it will be one that will actually work very well. And so let me actually show you what you're going to be doing in your homework here. I think it's the TD8 one. Yeah. So you can see that there's different pins here, and they're staggered. The pins are staggered in the sense that they're not dual inline. They're kind of a staggered pattern. I guess the reason they call it a SIP maybe a zigzag. I don't know, because you could kind of draw a zigzag going between these pins here. And so while it doesn't look like this shape might be correct, you can absolutely still use that. The thing you'll have to be a little bit creative on is actually the dimensions of the actual component. So try your best on that. And then you will have one component where you're going to have to create a pad stack for where, a footprint, I mean, where I am not giving you the pad stack for it. And that's going to be this particular device, which is for an LM317. Now, I will talk to you about that, especially with how we will name that particular component. That component is what is called a transistor outline, and it's got a JEDEC standard package. So the naming convention is TO-the JEDEC number. I will put this in the homework assignment as well, but the JEDEC number, or JEDEC, I think is how they pronounce it, is 220. And JEDEC is actually another organization out there for standards and naming conventions and things of that nature. So IPC is not the only one. So JEDEC is also another one, and there's others as well. Okay, so we will stop now.